Hi everyone. Today we will see about what is meant by power, what is meant by voltage, and then what is meant by current. So with the help of small experiment, so I will explain. So what is exactly for voltage, current as well as power. So here I'm in arrangement we are using the auto transformer here. So this auto transformer working with the help of transformer principle from 0 volt to 300 volt here, and also I'm using a voltmeter. So in this voltmeter it is a moving ion type voltmeter, so it will measure from 0 to 300 volt, and also the ammeter it will measure from 0 amps to 10 amps, and also the wattmeter, this wattmeter will measure from 0 to 3750 watts. And also I am here using some kind of resistive load. So resistive load means, so when the load is connected it will consume a high amount of current value, and then for the help of this experiment I will explain what is meant by voltage, current, as well as how the power is calculated with the help of P equal to VI cos pi. And also VI cos pi means I am using a resistive load, so that's why the cos pi value is 1. So only the power equal to P equal to V into I. So next I am starting the experiment here. So I am turning the auto transformer. So I am now the auto transformer, I am fixing the voltage as a 200 voltage here. So here the voltmeter reading is here. So I am connecting the voltmeter dial is 150 volt, but I am connecting 300. So we need to square the voltage value. So I am giving the voltage as a exactly 200 volt here. So that means it will shows the 100 volt into 200 volt. So now the current value is 0, and also the wattmeter reading is also 0 because there is no load is connected here. So now I am going to turn on the voltage load value here. 2 amps load I am connecting here. So it will 2 amps plus 1 amps, 3 amps load is here. So the ammeter reading it will shows 3 ampere rating. So 3 ampere into 100 volts or 200 volts. So that means P equal to V into I. So V equal to 200, I equal to 3 amps. So the power value equal to 600 watts. So here it will shows 300 watts here, unity power factor. So now the point is 1 and 2 is connected. So from this table, wattmeter table here, 1 and 2 connected for a 250 volt, the multiplication factor equal to 2. So I am going to calculate the value 300 into 2, 600 watts. That means exactly my load is consuming 3 amps current value, and also it will supplied by 200 volt. So the finally it will give 600 watts. That 600 watts is exactly showing this unity power factor wattmeter. So next time again I'm changing the load here, 2 amps to 4 amps. I'm turn on the 4 amps load, and then 4.5 amps here. So 4.5 amps into 200 volt. That means it will show that 4.5 into 200. So 4.5 into 200 means it will show that 800, and then point into 5 200 900 watts here. So 900 watts. So here it will show that 450 watts. So 450 watts into 2 multiplication factor. So it will finally arrive by 900 watts. So exactly what is meant by power rating, and then what is meant by voltage, current. So all those things solved by this experiment. So that means supplying the voltage into corresponding current value into cos pi value. So both are multiplying all those three things, it will show that the exact power value. So here resistive load, that's why the cos pi value equal to 1. If I am going to use an inductive load or a capacitive load, the power factor value may get changed. So from that power factor it will finally arrive by the various power factor. Okay, so this is the simple example for finding the voltage, finding the current value, as well as finding the current. So with the help of pure resistive load. Thank you.
I hope you understood the difference between voltage, current, and then power. Now we will explain it theoretically. The difference in electrical potential energy per unit charge between 2 points. So that is called as a voltage. So just we are considering an overhead tank, and also we are using a pump. So the pump is used to help to the energy, as well as now the stored water is called as a potential energy. So if the distance is very high, the potential energy value will increase. That means the potential energy, based on the potential energy, the current delivered value will be based on the voltage value. So voltage is nothing but it is a potential energy. Now for example, we are assuming that the height of the tank or width of the tank is based on the value. That means if the height still has a potential, that means it is a voltage. The voltage value will be a battery. So in real time example, we are comparing the overhead tank into the battery, and also the voltage we are call it as the difference in electrical potential energy per unit of charge between 2 points. The 2 points may be, for example, in DC power supply means anode as well as a cathode, but in AC power supply means based on the base and neutral. So that point we are considering A and then B. So that means A is topmost area as well as B is the bottommost area. If the area is increases, that means the potential energy increases, means the voltage value, the height of the voltage will also increases. So we are considering it is a 9-volt battery. So the 9-volt battery terminals are positive as well as negative. So this positive and then negative we are considering as a height of the tank, that means A and then B. So that is called as a electromagnetic force, EMF. The electromagnetic force increases, that means positive to positive attract, repel each other, negative to negative repel each other, positive negative attract each other. So we are considering as 1.5 volt battery here. So that 1.5 volt battery, from the anode and then cathode, here the negative electrons are flow from cathode to the anode. So that is for a 1.5 volt battery. So when remove the battery, there is no electron movement. That means the electron will still stand still in one particular condition, that is called as a current value. So the current will decide